Hello everyone, welcome back to the YouTube channel. Welcome back to the GCSE Maths series in particular. Today we're going to be looking at Nth Term. So yeah, let's just get straight into it. So on today's agenda, we're going to start off by looking at the key concepts, key definitions that you need to know before attempting any sort of questions. Then we're going to look at finding the Nth term, then using the Nth term. Then we're going to move on to a particular type of question that you seem to find in exams. So, is a number in the sequence? Usually, in the exam paper, you'll be given a sequence or an nth term, and you have to work out whether a certain number is in the sequence or not. But we'll get into that later. So, when it comes to the key concepts behind this, for today's lesson, a linear sequence is a list of numbers that increase or decrease by the same amount each time. This fixed amount is called the common difference. So, in today's video, we're going to be looking at linear sequences. This is part one, really, of the nth term topic. As you get later on to the GCSE content, you'll be dealing with quadratic sequences, but for now, we just have to worry about linear ones. So, it's just a sequence where from term to term, it increases or decreases by the same amount. So, if we're looking at the examples, so the first example here, we're looking at 3, 6, 9, 12, 15. You can clearly see that each term goes up by 3 from term to term, 3. The second one goes down by 3, 30 to 27, 27 to 24, and 24 to 21. Looking at the key terms behind this, we have term, which is just a number in the sequence. Term number is defined by n, which is just the position of that number in the sequence, and the common difference is obviously the number added or subtracted each time. So now we know our definitions, let's just get straight into some questions. And I'm going to teach you exactly how you're going to work out the nth term. So let's just rewrite this question. 6, 9, 12, 15. First of all, what we want to start by doing is work out the common difference between each term. You can clearly see that it increases by 3 each time. So we start off by saying the first part of the nth term is 3n. Then we look at the first term, in this case it's 6, and we do the opposite and go back a term in sequence. And because the terms are going from plus 3 onwards, we're going to minus 3 from 6 and get 3. So the nth term of this sequence is 3n plus 3. Again, let's look at question 2, 20, 17, 14, and 11. From term to term, we are minusing 3, minusing 3, minusing 3. So the first part of our nth term is minus 3n. We're obviously minusing 3 here, so we plus 3. We do the inverse, as we said before, and we get 23. So the nth term of this sequence is minus 3n plus 23. Now finally, looking at question 3, we're looking at 1, 4, 7, and 10. Each time, sequence is going up by 3, 3, 3. We then write our n, 3n. Then we do our inverse and go minus 3. 1 minus 3 is minus 2. So you just put that in right there. Okay, moving on. We have to apply our knowledge of nth term and say if... Okay, so we're going to use the nth term in this case. So the nth term of the sequence is 2n plus 3. Find the fourth term. So going back to our definitions, we can see that the term number is defined by n. And this is our position in the sequence. So when we're looking at this question here, we're trying to work out the fourth term, which means n is equal to 4. Okay, now using our formula for nth term, we have 2n plus 3. So what we want to do is plug in 4 into our formula. So when I put this in brackets, This means 2 times 4, which is 8, plus 3, which is equal to 11. So the fourth term is equal to 11. Looking at question 2, the nth term of a sequence is 7n minus 5. Which term is equal to 30? Okay, this is a bit of a different question where we're going to have to use our knowledge of nth term and use it in a different way. So the way we do this is we do 7n minus 5 is equal to 30 and set up what we call an equation. So we know that 30 is a term in this sequence, right? We know, which means that 7n minus 5 has to equal 30 at some point for some value of n, some position in the sequence, whether that be position 1, position 2, position 3, position 4, or say it's position 5 in this case. In the fifth term in the sequence is going to be equal to 30, just as an example. So we know for some value of n, 7n minus 5 is going to give us 30. So we solve this as it is an equation. So the first stage here is to get the numbers on the same side and get the n's on the same side. Obviously, in this case, there's only one n, and so we have to move the 5 over to the right hand side. So we plus 5 on both sides, and we get 7n is equal to 35. Then we divide both sides by 7, divide by 7, divide by 7, and we get n is equal to 5. Oh, so the example that I had made actually came true, and that this holds. So the fifth term in the sequence is equal to our 30. Okay, moving on. We have the nth term of a sequence is minus 3n plus 12. Find the second and the sixth term. Okay, again, it's like the first question. We're going to plug in n equals 2 for the second term, n equals 6 for the sixth term. So minus 3 brackets, which means times, plus 12. This is going to be equal to minus 3 times 2 is minus 6, plus 12 is equal to positive 6. Then that's for the second term. Let me just write that there. And then the sixth term, we get minus 3 brackets 6 plus 12, which is equal to minus 18 plus 12, which is equal to minus 18 plus 12 is going to be minus 6. So the second term is 6, and the sixth term is minus 6. Perfect. Okay, moving on. We're now going to be working out is the number in the sequence. So the nth term of a sequence is 3n plus 2 is 20 in the sequence. Okay, so going back to looking back at this can help us. Number 2 in particular, we knew that 30 was definitely part of the sequence. So at some point, our nth term formula was going to be equal to 30 at some point and give us a whole number for our value for n. So the way we check whether a number like 20 is in our sequence is by equating. Equating means form an equation. So 3n plus 2 is equal to 20. And if, when we solve this equation, we get a whole number for our n, we then know that that number is part of the sequence. Because if you were to think about it logically, we couldn't have, for example, n is equal to 1.345 whatever, because that is not a term in a sequence. Terms in the sequence are term 1, term 2, term 3, term 4. There is no middle term here for 1.345, so we have to get a positive, not positive, sorry. We have to get a whole number in this case. So, though we do this, minus 2 from both sides to get the numbers on the same side. So 3n is equal to 18. And then we divide both sides by 3 to get our value for n. So n is equal to 6 in this case. And then okay, so yeah, n is equal to 6, sorry for that. Um, so yeah, then we know that 20 is in our sequence, and in fact, it is our sixth term in the sequence. So, looking at number 2, the nth term of a sequence is 4n minus 5. What is the smallest number in the sequence greater than 50? So, we want to find out, so we want to find out the smallest number which is greater than 50. So, we just equate this 4n minus 5 is equal to 50. Actually, a better way would be to do this. 4n minus 5, the smallest number in the sequence greater than 50. So greater than 50. So we can see that the value of n is positive, which, going back to our page here, we can see that when it's a positive difference, as we were going from 6 to 9, from 9 to 12, that our n was positive. But in this case, number 2, it was negative because each term was decreasing from term to term. So we know that this is an increasing sequence. So the numbers are getting larger as the terms are increasing, which means that the smallest number greater than 50, no, which means that the numbers are getting larger. So once it gets past 50, so say the sequence bounces on 43 or something like that, then it goes to say 47 and then 51. We know that, okay, this is the point where the values become greater than 50, right? And we know that all the terms past this point will be greater than 50. Hence, the question says, what is the smallest number in the sequence greater than 50? So we are looking for the first term to hit above 50. So the way we do this is by an inequality. We set it up as 4n minus 5 is greater than 50, because we want to work out when the sequence is greater than 50. Plus 5 onto both sides of our inequality. 4n is greater than 55. And then n is greater than 55 divided by 4, which is, let me get my calculator, 55 divided by 4 is, n is greater than 13.75. Which means that every term, so let's say this is the 13th term, this is the 14th term, these two here, we can see that it hits 50 at this point in between the 13th and the 14th term, but we know that those cannot be accounted for because they simply just don't exist as terms in the sequence, as recognizable terms in the sequence. So we know that the smallest number where the sequence is greater than 50 will be our 14th term, because at this point it's less than 50, and then it hits 50, equal to 50 at this line, 13.75, and we know that from this point on it's greater than 50. So I hope that makes sense to you guys. 3, looking at the third question, the nth term of a sequence is 9n minus 4, and we want to work out, is 113 in the sequence? If so, what term is it? Okay, so similar to the first question, we equate the two, and if 113 is a value in our sequence, then we will be able to solve the equation and get a whole number for n as a recognizable term in the sequence. So start off by plussing 4 to both sides, and we get 9n is equal to 117. Then divide both sides by 9, and we get n is equal to 117 divided by 9, which is 13, which means that 113 is in fact in our sequence, and it is the 13th term. Okay, I think that's gonna wrap it up for today's video. I hope you guys enjoyed. Please like, comment, and subscribe, and stay tuned for the exam style questions episode, where we'll just take it a step further and just look at past paper questions. the most important part of maths in my opinion. So yeah, catch you guys in the next one.